The surface area and volume of a triangular pyramid. So the base of this pyramid is an equilateral triangle. So it's important that you realize the sides, the lateral sides, the up and down sides, are not necessarily, and are not in this case, equilateral triangles. Only the base is an equilateral triangle. So if we're going to find the surface area of this question, we need to first of all find the area of the base. We'll notice that each side of the base is 40. So here we have it. This is 40. This is 40. And this is 40, making this 20. Now remember that it's an equilateral triangle, so these are all 60, and these top ones are both 30. And then you're going to need to remember that it's the 30, 60, 90, that this side is the t, the height is t root 3, and the hypotenuse is 2t. We can see that t is 20, so the height is 20 root 3. And that's everything we need then to find the area, the surface area of this triangular pyramid. So the total area would be the area of the base, which is a triangle, an equilateral triangle. 1/2 its base, 40. Times the height, which we just figured out was 20 root 3. Plus, there are 3 triangles. Each triangle has an area of 1/2 base times height. We know that the lateral sides are all triangles. They're isosceles triangles. And we know that every base is 40. And they've given us in the picture that the height of each of these triangles is 7. So we'll multiply all that out. 1/2 times 40 is 20. 20 times 20 is 400. So 400 root 3 plus 3 times 1/2 times 40 times 7 is 420. And our label is meters squared. Quick reminder, you can only add square roots if they're like terms. If I ask you to add 5 root 3 and 2 root 3, you can do that. That's 7 root 3. If I ask you to add 5 root 3 and 2, you can't do that. They're not like terms. It's just like asking you to add 5x and 2. You can't add 5x and 2. You can't add 5 root 3 and 2. The root parts must be the same in order to add roots. So 400 root 3 plus 420, you can't simplify that unless you approximate and make it a decimal. Now let's take a look at the volume. Remember that the volume of a pyramid is 1/3 the area of the base, 1/3 times the area of the base, times the height. And the height is right there, the height of the pyramid, not the slant height, but the height is 6. So the first thing we need to do is use the fact that every base edge is 38. Remember, the base is an equilateral triangle, so we have 60 and 30, 60, 30, 90. And we can take half of 38 and figure out that this is 19, and that's our t, and our height is t root 3, and if we needed it, the hypotenuse would be 2t. From this we can see that t is 19, so the height is 19 root 3. Now we can find the volume. volume is 1/3 area of the base. Now remember, the base is a triangle. The triangle's area is 1/2 its base, which is 38, times its height, which is 19√3. So 1/3 the area of the triangle times the height. And the height of the pyramid was right there. It's 6 in the picture. So we'll work all this out. I would try to simplify some of the fractions first. Remember that the 38 is over 1 and the 19 is over 1, as is the √3. The 2 and the 38 cancel. That 2 goes into 38 19 times. 19 times 19 is 361. So we have 361 √3 over, and then we still have this 3. And I checked 361 divided by 3. That does not divide and make a nice number. We're not doing any decimals here. So this is our answer. Now you could write this way if you wanted. 361 thirds √3. Don't forget to label centimeters cubed. One final note to make life a little easier for you. Reducing these fractions can be a little tricky. Desmos, the graphing calculator on desmos.com, can do this for you very easily. Notice that I punched in 1/3 times 1/2 times 38 times 19. The trick is it will give you a decimal, and the trick is to hit this button right here. If you hit that button, it will reduce it for you and give it in simplest form. So I wouldn't punch the radical in, that's not going to help you. But remember, our answer was 361 √3 over 3. The tricky part is reducing that fraction, and Desmos can make that very easy for you.